This screencast is on nomenclature rules. Nomenclature is just a fancy way of saying naming rules. So we're talking about how we name compounds. There's going to be a set of questions that you want to ask yourself as you go through naming compounds. And so while I'm modeling that for you, these are the same types of questions that you should be asking yourself when you're working on naming compounds. Just a heads up, there are some things that you need to memorize, okay? And the sooner you just accept that and do it, the easier that this will all be for you. So make sure you're paying attention to what needs to be memorized and work diligently on getting that done, and it will make the entire process that much easier. This entire screencast can kind of be used as a process for how we name compounds. If you start at the beginning and you ask yourself a set of questions that I'm going to model for you, eventually you will be able to name your complete formula. Have patience and work through the process because it really is a process. But if you work with it, you will get there and be able to name complete formulas without much difficulty. Again, nomenclature is a naming system. So we're going to talk about naming systems for ionic compounds, which are made of ions. We'll also briefly talk about molecular compounds, which are not made of ions. But naming system of binary ionic compounds involves combining the name of the compound's positive and negative ions. So the name of the cation is given first, and that's followed by the name of the anion. For example, Al2O3 is aluminum oxide. We know that aluminum is the positive ion, and oxide is the negative ion. So the formula and the name follow with the positive ion first, the negative ion second. The ratio of the ions is not given in the name because it's understood based on the relative charges of the compound's ions. So again, we're talking about ionic compounds here in the charges, and so that's where we're getting this information from. And if you know the charges, then you don't have to look them up. The first question you want to ask yourself when you're looking at a chemical formula is, does the compound start with hydrogen? So for example, if I have CaCl2, that does not start with hydrogen. So I'm going to move on to my next question. But if, however, I have something like HCl, which does start with hydrogen, then I know that I am dealing with an acid. Here's a list of the acids that you will need to memorize for the test. HCl is hydrochloric acid, HBr, hydrobromic acid, HF, hydrofluoric acid, HI, hydroiodic acid, H2SO4, sulfuric acid, H3PO4, phosphoric acid, HC2H3O2 is acetic acid, H2CO3 is carbonic acid, and HNO3 is nitric acid. Again, these you need to memorize for the test. So go ahead now, make sure that you pause the video and jot these down and work on memorizing this before the test. So if we've passed question number 1 and our compound does not start with hydrogen, so again we're back to our example being CaCl2, then our next example is, are there only 2 elements and are they both nonmetals? Okay, so here, yes, there's only 2 elements, but calcium is a metal, so it's not both nonmetals. Now, how do I make sure that I know if something's a metal or a nonmetal? Remember, our periodic table looks like this. Okay, and over in the right-hand side in the P section, we have the staircase. Okay, to the left of the staircase are the metals, and to the right of the staircase are the nonmetals. So do we have 2 elements that are to the right of the staircase? If the answer is yes, then it is a molecular compound. And we've already done this. This is where we're using the prefixes to name how many of each element is in the compound. And just as a review, our rules are that you may use any prefix for the second element, but not mono for the first element. And the second rule is that you will change the second element to end with IDE. Possible prefixes that can be used are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And again, to review the IDE endings, we take the name of the element, for example, chlorine, and we just drop off the end of it and we substitute IDE for it. So we're changing the name ending. Oxygen becomes oxide. So we're doing this because those elements have a negative charge. Okay, same as we did with naming ionic compounds. Most of the prefixes make sense to me. The one that makes the least amount of sense is tetra, and actually that comes from the Russian for 4, which is tetris. Okay, so in Russian, 4 is tetras. That's where the 4 comes from for the prefix tetra. All right, let's look through some examples. When we start with CO2, my first question was, does this start with the element hydrogen? The answer is no. So my second question is it made up of 2 elements and are they both nonmetals? Carbon and oxygen are both nonmetals, so I'm going to name them using my prefixes. I don't use the prefix mono for the first element if there's only one, and I see that there is only one carbon here. So I'm going to name this carbon, and then I'm looking at the second element, the oxygen has a 2 associated with it. My prefix for 2 is di, so this is carbon dioxide. In my next example, CO, it does not start with hydrogen. It is 2 elements and they are both nonmetals. So my first element is carbon, and again there's only one of them, and I know I don't use my prefix mono on the first element, so I'm just going to name that carbon. My second element is oxygen, and because there's no subscript expressed, I know that there's only one of them. So now I do use my prefix mono for carbon monoxide. And PCl3 does not start with hydrogen. I am dealing with 2 elements and both of them are nonmetals. There is no subscript beside the P, so that tells me I have 1 phosphorus. Don't use the prefix mono on the first element, so I'm just going to name that phosphorus. Then in my second element, I have a subscript of 3. My prefix for 3 is tri, so this is phosphorus trichloride. And finally, I have N2O4. I see here that I have a subscript of 2 with nitrogen, so I'm going to use my prefix di-nitrogen. So I use any prefix other than mono with my first element, and in my second element I have a 4. My prefix for 4 is tetra, so this is dinitrogen tetraoxide. So we've asked, does the compound start with the element hydrogen? That was our first question. Our second question was, are there 2 elements and are they both nonmetals? So now we come to our third question. Are there 3 or more elements in the compound? So for example, do we have something like CaOH2, which is made up of 3 elements, calcium, oxygen, and hydrogen? If you have 3 or more elements in the compound, then that compound contains a polyatomic ion. And you will name the polyatomic ion using the name from the polyatomic ion list. And these are ones that you are responsible for memorizing. Again, we've talked about this already in class, which ones you're responsible for memorizing. Please note, you will need to follow through the rest of the questions to name the remainder of the compound. We're not finished yet. This compound is going to be ionic, but remember, a polyatomic ion contains covalent bonds, but it's still an ionic compound, even though part of it is bound together covalently. So, are there 3 or more elements? It's a polyatomic ion somewhere in the formula, and those are going to be ones that you need to memorize. Remember the polyatomic ions that you're required to memorize: acetate, cyanide, chlorate, hydroxide, nitrate, nitrite, carbonate, chromate, sulfate, sulfite, phosphate, and ammonium. Make sure you're familiar with the symbols, the charges, and the names of these polyatomic ions. The next question we want to ask ourselves is there a transition metal, indium, thallium, lead, or tin in the compound? If so, then there is a metal that has more than one oxidation state. So this means it has more than one type of charge. And in this case, chemists use what's called the stock system of nomenclature to indicate the charge. And in the stock system, the charge is going to be represented by a Roman numeral. Okay? So our Roman numerals are I, 2 I's, 3 I's, IV, V, and VI for 1, 2, 3, 4, 5, and 6. Very rarely do you have a Roman numeral that will go above 6. The compound is going to be ionic, and you may need to continue through the rest of the process to name the remainder of the compound. So for example, Fe plus 2 is iron 2. Okay, so the Roman numeral 2 matches the charge of 2 on the ion. Fe plus 3 is iron 3, and again, the Roman numeral 3 matches the charge of 3 on the ion. So how do we know what the charge is going to be on the ion? Remember that we look up the charge on the other element. We multiply down, so we take the charge times the subscript to give us the total negative charge. Because our ionic compound is neutral, we're going to have the same number of positives as total negatives. So we want to write the positive charge that matches the negative charge, and then we're going to divide the total positives by the subscripts, and that will give us the charge of the ion or the Roman numeral. Let's look at an example. In V2O5, we don't know what the charge is on vanadium, but we do know, based on its location on the periodic table, that oxygen has a -2 charge. We're going to take our -2 charge times the subscript, so we multiply down, and we get a total negative charge of 10. Because our ionic compound is neutral, we know that we must have a total of +10 charge as well. We're going to take this +10 charge, and we're going to divide it up by the subscript for the vanadium, and that gives us a +5 charge. So we know that the metal ion here is going to be vanadium 5. Let's practice with these compounds. For FeOH3, I know that the charge on my OH hydroxide polyatomic ion is -1. So I take my -1 times 3, okay, and I multiply down and I get a -3. That means my positive charge has to be +3. I divide up by my subscript on the iron, which in this case is 1, and that gives me a charge of +3 for the iron. So this is going to be iron 3 hydroxide. In my second example, I have copper and sulfate. So I'm going to, here, let me separate this here. For copper and sulfate, CuSO4, okay, I know that my SO4 has a charge of -2. Okay, now remember that's for my entire SO4 grouping, and I only have one of those, so when I multiply down, I get a total negative charge of 2. To balance that out, I need a total positive charge of 2, and when I divide up by 1, I see that I get a charge for my ion of 2. So this is copper 2 sulfate. For my last problem, I have cobalt and sulfur. So when I write the charge for sulfur, I know that it's a -2 based on its location on the periodic table. I multiply down and get a total -6 charge. That means I must have a +6 charge on the positive ion side. I divide up, so 6 divided by 2 gives me a +3. So this is going to be cobalt 3 sulfide. Our last question is, what is left that you have not already named? The compound at this point is going to be made of 2 ions. It's a binary ionic compound. You should have all the pieces of your compound named after this question. So your question needs to be, does it have a positive charge? If it has a positive charge, we use the element's regular name. Does it have a negative charge? If so, we need to change the ending to IDE. Write down these practice problems and then work your way through the 5 questions trying to name these compounds. Pause the video and write your answers, and then check your answers when you're finished. AlCl3 is aluminum chloride. This is a simple binary compound because it's just 2 elements straight from the periodic table. PbCO32 is going to be lead 4 carbonate. This one is complicated because it involves a polyatomic ion and also an element that requires the use of a Roman numeral. CCl4 is going to be carbon tetrachloride. This one is a molecular compound because there are 2 nonmetals. HC2H3O2 is acetic acid. This is one that you need to memorize, and we know it's an acid because it begins with hydrogen. LiCN is lithium cyanide. Remember that Cn is a polyatomic ion, and Hg3PO4 is mercury 2 phosphate. Again, this one's a little more complicated because it involves a polyatomic ion as well as a transition metal. As I've illustrated throughout this screencast, make sure that when you're writing the names for compounds, that you're going through this list of 5 questions. You want to make sure you write the questions down in your notes and you're asking yourself these questions as you're working on naming. Please write down any questions you have and ask Mrs. Benke in class.